This is our project. In this project, we implement a student management systems that can imitate a class and manage the student in a class. The student management system have covered most of the knowledge about C language we learned in class. Those knowledge includes basic arrays of C, 2D arrays, loops, recurse, C pointer, function pointer, random number, bubble sort, binary search, C structure, linked list, and so on. And let's run the project. We enter 100 as the class type. Press C to continue. And this is the result. Let me explain how the project works. The first part of our project is two construction. They respectively construct a new data type student and a list node. In the student, it contains two data types, which are student ID and the age of the student. And the list node is the core of the linked list, which contains its own data and a pointer that points to the next data. The first part of the main function initializes each necessary data, which have a random initializer, a start time record, a class in array, and a class in 2D array. It also scans users' input as the size of the class. This part set the minimum age and the maximum age of all the students and use random number to create their student ID and age. I repeat this code several times to better control the project progress. It reads users' input and continue if users press C. This part of the project prints each student in a recursive way and then put them into 2D array. The first function can convert an array version of class into 2D array to make it easier to access the data. And the first column of the array is student ID, and the second column of the array is the age of the student. Each row represents a student. And the second function recursively prints each student data. It passes a function pointer that can specify which data should be printed. This part of main searches the student by their student ID. This function implementation is the typical binary search implementation. It can search in a sorted array. Because the student ID is arranged in a sorted way, so the binary search should also work in this condition. Also, the binary search is faster than normal search, especially when the data size goes big. It has O log n time complexity compared to O(n) of the normal search. In this part of the main, use linked list to divide the class into two groups. One group contains the student with age under 21, and the other group contains the student with age equal to or more than 21. Here is the whole logic of the method. It first determines whether the age is less than 21 and grant each student their group name, which are 0 and 1. Then insert the data into the linked list and print them in order. In the insert function, there is a special implementation that it checks the priority of the value, which easily divides students into groups. The reason why we chose to use linked list is because it has strength in modifying list, like adding, deleting, and so on. We don't need to change the data in dividing into two groups. Only we need to add and delete. Therefore, we use linked list rather than normal array. This part of the main sort the class by their age, and the implementation is the typical way of barbell sort. The last part of the main function calculate and print the overall execute time and export all the output into a text file. We also did some time analysis in this project. When the class size is equal to 10, the average time is 0.002904, which is a very stable data. When the class size is equal to 100, the average data is 0.001480, which is much more unstable. And when the class size is equal to 1,000, it becomes 0.016790. And when the class size is equal to 10,000, it took 0.363985 seconds to execute. It shows that the size grows faster, the time consumed grows faster too.